Imagine you're sitting in a hospital emergency room.
Yeah.
You feel relatively fine, maybe just a little severe indigestion. But suddenly the surgical team just rushes through the doors and they're prepping you for an emergency appendectomy.
Oh, wow. That's terrifying.
Right. You are terrified. And you're wondering, why is this happening? Well, it's because an artificial intelligence algorithm, which was scanning your vitals and your intake forms, was 99% confident your appendix was about to burst.
Yeah, 99%.
Exactly. And the really terrifying part is that the algorithm wasn't technically broken. I mean, the math was running perfectly. It just it didn't know how to say, I don't know.
Yeah, that scenario that is the exact nightmare keeping hospital administrators awake at night right now.
I bet.
A highly confident, highly advanced system that just totally lacks the context to understand human nuance.
Well, today's deep dive is about how the medical field is actually trying to prevent that exact nightmare.
Right.
We're unpacking this fascinating, just really comprehensive syllabus from the Clinical AI Academy.
It's an incredible resource.
It really is. It's for their online certificate course, and it's titled AI Literacy for Healthcare Professionals. And,
Yeah.
whether you are a practicing clinician, a medical student, a hospital manager, or let's just be incredibly real here, someone who will inevitably be a patient one day, understanding how doctors are being taught to use AI is absolutely crucial.
Absolutely.
It's crucial to your health, your bodily autonomy, and obviously your safety.
Yeah, and the scope of this source material is really a testament to how fast medicine is changing. I mean, we're looking at an extensive self-paced online course. It's got 8 modules.
So it's the real deal.
Oh, completely.
Mm.
It's casting this massive net across nurses, pharmacists, allied health professionals, doctors.
Wow.
And the fundamental argument here, which I love, is that healthcare workers do not need to become software engineers.
Right. They don't need to be sitting there writing Python code.
Exactly. They don't need a coding background, but they desperately need a reliable, evidence-based framework to evaluate, question, and ultimately safely use these tools.
Okay, let's unpack this, because the very first hurdle for a doctor or a nurse is actually unlearning what they already know about software.
Yes. Unlearning is the perfect word.
Because hospitals have been full of software for decades, right? I mean, electronic health records, digital lab results, scheduling systems.
Right, but traditional software operates on entirely different principles than artificial intelligence. And the syllabus makes drawing that distinction its absolute first priority in those early modules.
Makes sense.
Because traditional software relies on explicit rules-based logic, right? Like a human programmer sits down and writes a definitive instruction.
Like an if-then statement.
Exactly. If the patient's heart rate drops below 60 beats per minute, trigger a red alarm on the monitor.
Yeah.
The software is just blindly following a script.
Yeah, I like to think of traditional software as like a very strict baking recipe.
Well, that's a good way to look at it.
Yeah, you just follow the exact steps, you measure the flour, you bake at 350 degrees, and boom, you have the cake. It does what it is told every single time.
Right.
But AI is totally different. AI is more like a chef who learns to cook not by reading a recipe, but by tasting thousands and thousands of meals.
I love that analogy.
Thanks. I mean, it internalizes patterns from the data it's fed. But that immediately makes me wonder, if it learns by tasting, what happens when it is fed bad data?
Or biased data, yeah.
Exactly. Or data that just doesn't represent the people it's actually going to be treating in the clinic.
So the curriculum dives deep into that exact vulnerability. It really pulls back the curtain on how machine learning models actually develop.
Right.
Because if your AI chef has only ever tasted highly salted food, it naturally assumes everything in the entire world should be heavily salted.
It doesn't know any better.
Exactly. And in a clinical context, I mean, the stakes are literally life and death. If an algorithm is trained predominantly on health data from a specific demographic, say, men between the ages of 30 and 50, its predictive power might completely plummet when it encounters a female patient.
Or an elderly patient.
Exactly.
People always use the phrase black box to describe this stuff, which makes it sound like, I don't know, dark magic or something.
It does sound a bit sci-fi.
Yeah. But I prefer to think of a neural network like a massive, highly complex game of telephone.
Oh, that's interesting.
Yeah, you feed millions of data points into one end, and they get passed through countless hidden layers of mathematical weights and connections. Each layer just whispers to the next. And by the time the final diagnosis pops out the other side, it is incredibly difficult to trace exactly which whisper caused that final output.
That game of telephone is exactly why medical professionals have to understand the training process.
They have to know how the sausage is made.
Exactly. The AI is not thinking or reasoning the way a human doctor does. It's purely pattern matching, based solely on its past exposure. And knowing that a model will inherit the blind spots of its training data, that's the first step in using it safely.
So they're learning its limitations.
Yes, clinicians are basically being taught that they have to know what the machine doesn't know.
Which perfectly sets up the next major hurdle in the course.
Yeah.
Since we now know AI learns from historical data and can definitely go astray, how does like a hospital procurement officer actually know if an AI tool works
Right, before they buy it.
before they trust it with your body? Let's play the skeptic for a second here.
Okay.
If a tech vendor walks into my office, drops a glossy brochure on my desk, and promises their shiny new AI diagnostic tool is 99% accurate.
Well, the famous 99%.
Right. How do I know I am not just being sold modern-day snake oil?
You are hitting on a massive threat model in modern healthcare.
Really?
Oh, yeah. And the course arms clinicians against that exact vendor scenario by teaching them a completely new vocabulary for evaluation.
Okay, what kind of vocabulary?
Well, the very first thing they learn in Module 3 is that accuracy is actually a terrible, highly misleading metric in medicine.
Wait, really? Why is accuracy terrible? I mean, 99% sounds pretty great to me.
Okay, so imagine a rare disease that only affects 1 in 100 people.
Okay.
A tech company could build an AI that simply outputs the phrase, "you are healthy," every single time.
Just automatically.
Exactly, without even looking at your chart or your symptoms. And out of 100 people, it will be correct 99 times.
Oh, wow.
Right. So it can legally boast a 99% accuracy rate on that brochure while being completely, utterly useless as a diagnostic tool.
Because it missed the one person who actually had the disease and needed life-saving care.
Exactly. It missed the one case that mattered.
Oh, man. So it completely fails the actual task, but the math looks perfect on a billboard.
Yeah, and to combat that, the syllabus trains professionals to demand data on sensitivity and specificity.
Okay, let's define those.
Sensitivity is the tool's ability to correctly catch the people who actually have the disease. And specificity is its ability to correctly identify the people who do not have the disease, which is what minimizes false alarms.
I always think of airport security for this.
Oh, wait.
Yeah, like the metal detector at the TSA checkpoint has incredibly high sensitivity.
Right,
It will catch every single gun or knife that walks through.
definitely.
But it has terrible specificity because it also goes off for belt buckles and keys and like foil gum wrappers.
Right, the false alarms.
Exactly. And in a hospital, if an AI flags every single patient in the ICU as high risk, it has perfect sensitivity.
Yeah.
But for a nurse working a grueling 12-hour shift...
An alarm that rings every 5 minutes for no reason is an alarm that eventually gets ignored.
Exactly. It creates severe alarm fatigue.
And alarm fatigue is a massive patient safety issue.
Sure.
So the course also dives into a metric called OROC, which stands for Area Under the Receiver Operating Characteristic Curve.
Okay, I am definitely going to need an analogy for AROC. That is a mouthful.
It is a mouthful. So think of AORC as a grading system for how well the AI can separate two distinct groups, like the sick patients from the healthy ones.
Okay, tracking so far.
Imagine you are in a pitch-black room and you're trying to separate a pile of apples from a pile of oranges just by touch.
Okay.
An AORC score of 0.5 means you're just guessing randomly, tossing fruit left and right.
You have no idea what you're holding.
Right.
Right.
But a perfect score of 1.0 means your hands can perfectly identify every single apple and every single orange.
Oh, that makes so much sense.
Yeah, clinicians are learning how to demand those specific AOC scores from vendors, just to see how well the AI actually distinguishes between diagnoses in the real world, rather than just accepting a blanket accuracy claim.
That is such a powerful tool for them to have. And then there is calibration. This concept really stood out to me in the source material.
Calibration is huge.
It is essentially asking, does the AI's confidence level actually match reality?
Exactly. Calibration is the difference between confidence and competence.
Right.
Think of a weather forecaster. If the forecaster says there's an 80% chance of rain, you expect it to actually rain 8 out of 10 times they make that specific prediction.
Right. If they say 80% every day and it never rains, they're uncalibrated.
Precisely. So if an AI says it is 90% confident a tumor is malignant, developers actually track if it is correct 9 out of 10 times in those scenarios.
Wow.
If it is only correct 6 out of 10 times, the model is uncalibrated. It is wildly overconfident.
And an overconfident AI giving medical advice sounds like a massive lawsuit waiting to happen.
Absolutely.
But, learning all these mathematical terms in a vacuum is one thing. How does the course actually ground this in the messy, chaotic reality of a real hospital?
Well, the syllabus uses evidence-based walkthroughs of landmark clinical AI studies to prove how tools fail in practice.
Give me an example.
There is this famous case study often discussed in clinical AI circles where a model was trained to detect pneumonia from chest x-rays. And in the pristine environment of the research lab, its scores were just off the charts. Beautiful metrics.
99% accurate, probably.
Right. But when they deployed it into a real hospital, its performance completely tanked.
What happened?
It turned out the AI had not actually learned to identify the visual markers of pneumonia in the lungs.
Wait, then what was it looking at?
It had learned to identify which specific X-ray machines were used in the intensive care unit versus the outpatient clinic.
You're kidding?
No, it simply associated the portable scanner that was used in the ICU with sicker patients.
So it was reading the metadata, essentially, not the lungs.
No, exactly.
That is incredible. And that is exactly why a hospital manager needs a checklist of the right questions. Like, show me your calibration data. Show me how it performs outside of your lab.
Yep, they need proof.
But here's where it gets really interesting.
Oh, yeah.
Yeah, because evaluating a narrow, specific tool, like an AI that only looks at lung x-rays, is one thing. But the syllabus also tackles conversational AI.
Right, Module 7.
Yes. We are talking about large language models, or LLMs, like ChatGPT and Claude. And I have to push back hard here.
Go for it.
Using a general-purpose chatbot for a medical workflow sounds incredibly reckless to me.
It definitely can be.
Right. I mean, if a doctor types my symptoms into ChatGPT and it invents a fake diagnosis, who is responsible? And what about my data privacy?
Well, the course completely validates your concern. It does not gloss over the severe risks of using LLMs in medicine at all.
That's a relief.
In fact, it explicitly dissects the phenomenon of hallucinations.
Right, when the AI just makes things up.
Exactly. But to understand why an AI lies, clinicians have to understand the underlying mechanism.
Okay, how does it work?
An LLM is not a search engine querying a verified database of medical facts.
Yeah.
It is essentially a wildly sophisticated version of the autocorrect on your phone.
It's just guessing the next word.
Exactly. It is calculating the mathematical probability of the next word in a sequence.
So it is just a confident liar.
Basically, yeah.
It strings together a sentence that sounds highly professional, uses all the correct medical jargon, and yet is medically completely fabricated.
It will confidently invent entire medical studies, complete with fake authors and fake journal titles, just because those words statistically look good together.
That is terrifying.
Yes. So to counter this, the course trains clinicians on prompt engineering.
Oh, like how to talk to it.
Right. Instead of just asking an open-ended question like, what is wrong with my patient? You have to mathematically constrain the AI's prediction space.
How do you do that?
You give it a strict persona, you instruct it to only pull from the specific clinical notes that you provide, and you demand it cite its sources from that uploaded text.
So you are building strict guardrails around its guessing game.
Exactly.
But what about the data protection aspect? Because entering my sensitive health information into a public website run by a tech company in Silicon Valley, I mean, that is a massive privacy violation.
Pasting patient data into a public LLM is a blatant IPA violation.
Yeah, I'd imagine.
And the course lays out the institutional governance required to prevent that from happening. Hospitals are having to deploy secure, localized enterprise versions of these models where the patient data never actually leaves the hospital's own private servers.
That makes a lot more sense.
Yeah, and this ties directly into the broader concept of trustworthy AI that the syllabus covers. Operating AI in healthcare is not just a technical challenge, it's deeply tied to professional medical ethics.
Right, because if the AI hallucinates a lethal drug dosage and the doctor blindly prescribes it, it is the doctor's medical license on the line.
Exactly. Not the software developers.
Wow.
The curriculum emphasizes that clinicians have a shared professional responsibility to actively identify bias and ensure fairness in these tools.
You can't just pass the buck to the computer.
No, you cannot outsource your medical judgment or your ethics to an algorithm. And to enforce those ethics, the training dives into the dense regulatory landscape.
Oh, the red tape?
The necessary red tape. The days of Silicon Valley's move fast and break things mantra absolutely do not apply to human health.
Thank goodness.
Learners are walked through the FDA's SAM-MD framework, which stands for Software as a Medical Device.
I really want to understand the mechanism there. How does the FDA regulate lines of invisible code as if it were a physical device, like a pacemaker or a scalpel?
Well, the FDA evaluates the potential risk of the software's output.
Okay,
So if an AI is just analyzing hospital shift schedules to optimize nurse staffing, it is considered low risk.
makes sense. Nobody dies if the schedule's a little off.
Right. But if the software is analyzing an ECG reading on your smartwatch to detect an irregular heartbeat or looking at a brain scan to recommend surgery,
That's high stakes.
the code itself is legally classified as a high-risk medical device.
Wow,
It has to undergo rigorous clinical trials and validation, just like a new pharmaceutical drug.
that is fascinating.
And the course also covers international frameworks like the EU AI Act. That act categorizes AI systems by risk level and enforces strict transparency requirements before a tool can even enter the European market.
It is a massive amount of information to navigate.
It really is.
Which brings us to the final and possibly the most difficult hurdle.
Oh, implementation.
Yeah,
Hmm.
because understanding the metrics and the hallucination risks and the FDA regulations on paper is one thing, but actually deploying these systems into a living, breathing hospital environment is entirely another.
That's the hardest part.
Right. I mean, we are talking about wards with constantly rotating shifts, exhausted staff, emergency codes going off. Rolling out AI in a hospital isn't like installing a new app on your smartphone.
Not at all.
It feels much more like bringing a brand new, highly unpredictable doctor onto a surgical team. How does a hospital actually manage that level of disruption?
Well, workflow redesign is where most clinical AI deployments actually live or die.
Workflow redesign.
Yeah, a perfectly calibrated, FDA-approved algorithm will completely fail if the daily clinical workflow does not support it.
Because no one will use it.
Exactly. The course outlines the practical, on-the-ground reality of deployment. If an AI diagnostic tool requires a nurse to log into a separate computer system and click 10 extra times during a chaotic 12-hour shift,
Yeah, forget it.
they simply will not use it.
It has to be seamless. If it adds friction to their day, it is just dead on arrival.
Seamless integration is the ultimate goal, and that requires bringing the actual end users, the nurses, the technicians, the frontline staff, into the planning conversation long before the software is ever even purchased.
You have to talk to the people doing the actual work.
The syllabus focuses heavily on this stakeholder engagement and comprehensive staff training. But crucially, it also emphasizes post-deployment monitoring.
Meaning the work does not stop when the software is turned on.
Exactly.
Because the AI's performance can degrade over time.
Yes. Because medical practices change, populations shift, and new diseases emerge.
That makes sense.
This phenomenon is known as model drift.
Model drift.
Okay. So if a diagnostic model was perfectly trained on lung data from 2019, it would have absolutely no idea what COVID-19 looked like on a scan in 2020.
Oh, wow. It would just be completely lost.
Its accuracy would plummet overnight. So you have to continuously audit the software in the real world to ensure it's still performing as expected.
I imagine this requires massive institutional oversight. You can't just leave it up to the IT department to monitor patient outcomes.
Definitely not. Hospital AI governance committees are becoming a mandatory part of modern healthcare administration.
Who sits on those committees?
You need a cross-functional team. Doctors, ethicists, data scientists, and legal experts all overseeing these tools.
That's a serious operation.
It is. And the course stresses the absolute necessity of audit trails.
Like a paper trail.
Yeah. If an AI recommends discharging a patient, but the human doctor disagrees and decides to keep them overnight for observation, there must be a clear, traceable record of that disagreement.
And the medical reasoning behind it.
Exactly. The ultimate safety net woven through all this training is giving clinicians the power and the confidence to override the machine.
So, what does this all mean for you and me?
It's a good question.
When you zoom out and look at this entire syllabus from the Clinical AI Academy, it really represents a monumental shift in how we view modern medicine. Huge shift. We have officially moved past the hype phase of artificial intelligence. It is no longer just a novelty for tech enthusiasts or, a specialized tool strictly for coders.
That's right.
AI literacy is now being framed as a mandatory core competency for doctors, pharmacists, nurses, and medical students.
It's becoming foundational.
Yeah.
Yeah.
If you want to safely navigate the healthcare system today, the people taking care of you have to know how to interrogate a machine learning model just as critically as they read a blood panel.
There is a detail embedded deep in the final module of this course that I think extends far beyond the hospital walls.
Oh, yeah. What's that?
Healthcare professionals are specifically being trained on when to halt the deployment. Yeah. They are taught to recognize the subtle warning signs of a failing AI system, and they are given the strict protocols to pull the plug, shut the software down, and revert to human-only systems to protect human lives.
Knowing exactly when to hit the emergency stop button.
Exactly. And it makes you think, if the medical field recognizes the critical, life-saving importance of knowing exactly when to halt the deployment of a failing AI system, what criteria are you using to decide when to halt the deployment of AI in your own daily life and workplace?
That is a great question.
As these tools seep into our emails, our writing, and our daily decision-making, the ability to see through the mathematical hype, recognize a black box that isn't actually serving you, and simply pull the plug might be the most important literacy skill of all.